Gone are the days of stitching together proprietary services to make your app real-time. Now, it's as easy as use Socket. Solid Socket is an extension to Solid Start that adds powerful capabilities and APIs to make building real-time apps as easy as regular client-side apps. Let me show you how. So we have a very simple counter component here. You can see that every time we click the cloud button, it increases the count and logs it in the console. Pretty straightforward. To make this real-time, all we are going to do is take the stateful part, go to a different file, create a counter hook like this, and paste the stateful stuff in here. And we can return our count and increment function. Pretty straightforward if you've made any sort of custom hooks before. We can go into our counter component now and replace this logic with our counter hook, something like this. But this doesn't do much. All we did is reorganize our code a little. Let's come back to this file and add a use socket on top. One other thing is we have to wrap our count signal that we returned from this use counter hook with this create socket memo function. That's all we need to do. Now when we go back to our counter component and we hit the count button, we see it still works, but we don't see any console logs. That's because the logs are here on the server. You can see if we go back, make it 6, and come back here, our count is now at 6. So all this logic is now running on the server over WebSockets. We can even see the WebSocket messages flying around. Now if we were to pull the signal out into the global scope, we've just made our counter multiplayer, which means multiple users can now update and look at the same count. So that was a pretty simple example, but it can kind of show you how powerful these new primitives are. Let's try to do something a bit more advanced. Let's build some user presence functionality, or basically a way to show if there are other users looking at the same page and where their cursors are. We're going to start by creating a global signal that has all the current users that are live on any page, along with their X and Y positions. Then we're going to create a hook, which is going to take the mouse position as the input, or a signal of the mouse position as input. We're going to generate some random color, user ID, and a random name for every user that connects. Then we're simply going to listen to our mouse position input signal and set that into our global presence signal. Finally, we're going to return our presence signal wrapped with create socket memo so that we can listen to it on the client. Now we are going to come back to our counter page, and we can use this use mouse position hook that comes straight from the solid primitives library, and we're going to get our signal of X and Y coordinates from this library. Then we're going to call our use presence hook that we just created on the server, and we're going to pass in our mouse coordinates wrapped with, once again, a create socket memo. This is going to ensure that the signal that has been created on the client side can be transported and listened to on the server. Now here we're going to use something called a projection. Basically take all the input that's coming from the server and reconcile it with the input that we already have to make sure we only notify the things that actually change. Now all we need to do is to loop over all the users in our presence store and show an avatar for each of them. And down here, we're once again going to loop through all the users and show a cursor for all of them. Let's see what this looks like. So it kind of works. Right now it shows us that we are online, and it kind of shows our own cursor back to us. And as soon as we add a new user, you can see that we can now see both of these users up here. We even see the tooltip that shows our other user, and we can go back to our other window and see the mouse moving around. But there's a couple of problems with this right now. The first obvious one is that we shouldn't see ourselves in this list. We should only see the cursor of the other users that are currently on this page. The other problem is if I refresh this other page, it just adds a new user. We're never cleaning up the users from our presence signal once they disconnect. Let's fix those really quickly. We're going to come back to our use presence hook and add an onCleanup function, which once again just from solid.js. And on cleanup, we're going to remove the current user from our presence signal. Then we're going to create a memo that gives us all the users from the presence except for ourselves. And instead of returning the presence signal itself, we're going to return this other users, once again wrapped in our create socket memo. Let's see what this looks like now. Now we only see the other user that is signed in on the page instead of both of them. And if I close this tab, you'll see that it disappears from our original window. There you have it, user presence implemented in barely 50 lines of code. So let's do a quick recap. We add this new directive use socket on top of a file if we want it to run on our WebSocket servers. And we use create socket memo to wrap any signals that we want to transport over WebSockets to the other side of the network. If this feels interesting to you, please do me a quick favor and hop over to the SolidHack submissions and give this project a vote. And while you're there, please check out some of the other fantastic projects that have been submitted to SolidHack as well. But if you're not convinced yet, Stay tuned because there's so much more that we can do with these primitives. Because we got fine-grained updates using deeply nested stores. We got persistent signals that sync across different servers. We have cookies for authentication with no extra work. And we got a simple but really powerful sync engine for local first apps. Let's build a ToDo app that shows all of these features. We're going to start our ToDo app by a simple useSocket file. Now to work with the sync engine that's built into SolidSocket, first we have to define some events. These events are basically things that are going to happen to our to-do list, and we're going to keep a record of these events. Then we're going to create a signal that is going to contain all of our event logs. So you can think of it like a map that maps a string or an ID to a log of these events. And each log of events is our to-do list application, or the state of our to-do list application. Then we're going to create our useServer to-dos hook that is going to expose this functionality to our client. And here we're going to use our createServerEventLog primitive that comes from the SolidSocket library. Now this primitive accepts 3 parameters. The first one is the ID of the log that we want to access. Right now we're going to leave this to an empty string. We're going to come back to it later. The second parameter is the signal for the entire map of all the logs. And the third parameter is a setter for all the event logs. And what we get back from this primitive are 2 functions. Server events is a signal that is the event log that is marked by this ID. So you can think of it as the same thing as to-do logs of list ID. And it gives us this append event method, which is a way for us to append a new event to this log. Now all we need to do is to return these two to the client. And obviously we're going to wrap our server event signal with our create socket memo so that we can ensure it can be accessed on the other side. Now we're going to come to our client side, which is our ToDo app component. Now all the UI is already built here. So all we need to do is, first of all, call our userver to-dos hook that we just created under a useSocket file. Then we are going to use the client version of this event log. So remember, on the server, we used this create server event log, and here we're going to create the client event log. This is going to wrap our server event log that we get from here, and it's going to give us back the same 2 methods, a signal to access all the events and a method to append a new event to the log. This client event log will ensure that the client and the server stay in sync. So every time we append an event to our client log, it's going to also add that to our server log through this input that we have passed it in. At the same time, it's also going to listen to updates from the server and make sure that the client log is updated with it. But what exactly do we do with this log of events? Well, that's a great question. We can start to create these projections out of these logs of events to build up state. So we can use our create event projection, which is another primitive that comes from in the library. Going to take our event log as the first input and a reducer function as the second. This function is going to handle all the different events that can be in our event log, and they're going to mutate the state of the accumulator for each event. Under the hood, the create event projection primitive uses a solid store, which means it's mutable and it's fine-grained reactive. The logic here is pretty straightforward. If we see a to-do added event, we simply add that to-do into our accumulator. If we see to-do toggled, we're going to look for that to-do and switch the completed flag. If we see that the to-do has been deleted, we're going to remove that from the accumulator. And if it has been edited, we're going to change the title to our new title. That's it. Now that we have our list of to-dos, we can do a filter on it. So if the user wants to see only the active or only the completed to-dos, we can very easily implement that on top using a create memo. We can also simply keep building these projections. So for example, we can have another projection that only shows the remaining to-do. Then all we need to handle here are to-do added, toggled, and deleted. We don't care about the to-do edited event because this is just an array of all the to-do IDs, not their title. If we don't need objects or arrays and we just need simple primitive data types, we can use create event computed. So here we're calculating the total amount of to-dos that we have by simply listening to the to-do added and to-do deleted events and incrementing or decrementing our counter. At the end, it's going to give us a signal of a number that tells us how many total to-dos there are. Now this is how we can build up our state in response to these events. The best part about these projections and these computeds, they don't always need to run from scratch. Every time there's a new event that comes in, either from the server or by calling the append event method, this function only needs to run once for the new event, as it can just simply build on top of the existing state that we have already computed based on the existing events. Now to actually do things with our event log, we can go into our UI and simply call this append event method with the type of event we want to emit. So here, when the user submits the to-do add form, we can simply append the to-do added event, and that's it. Or when they want to toggle a to-do, we simply append the toggle to-do event. If they want to delete it, we simply append the to-do deleted event with the ID. When they want to edit a to-do, we append the to-do edited event with the ID and the new title. To implement something like clear completed, filter all the to-dos that have been completed and emit the to-do deleted event for each one of them. Let's see how well this works. So here's our to-do application. Now if I go in here and add a to-do like this, we're going to call the append event method, and it's going to append that event into our client log first. Now, as soon as that event is appended into the client log, our projections immediately respond to it and update our state, which then update our UI. So our UI updates are always next frame, very instant, and they don't wait on the network. Behind the scenes, our client event log is going to try to append that event on the server as well. And if the server says everything is good, then nothing happens because the event is already on the client as well. But if the server for some reason disagrees, this event will simply be removed from the client event log and the state will be rolled back. We can even have multiple users looking at the same to-do list, but ideally we want different users to be looking at different to-do lists and not all be looking at the same one. Let's see how we can implement some authorization in this. To get some auth working, all we need to do is bring our use cookies hook in here. This is going to give us access to the request cookies at the time that this WebSocket connection was established. Now, one of the biggest advantages of this approach to WebSockets is that they run on the same domain as our actual servers, which means when the user authenticates with your existing backend, your auth service is going to set some cookies which you can very easily access right in your WebSockets without an additional layer of authentication. We can use the user ID from this cookie as the ID of the to-do list that we want the user to be able to access. Now, if I have two different users logged in as two different users, they're going to be on two independent to-do lists, and it's not going to cross over from each other. One user will never have access to another one because the server filters them out based on the cookie. So we got authorization working, but what happens if we quit the server and start it again? Well, we're going to lose all the state because all the data lived inside a signal, and a signal only lives in memory. Quickly fix that. All we need to do is to take the signal and replace it with or create persisted signal. This primitive once again comes from the SolidSocket library, and to make it work, you need to pass in a storage object and a key. The storage object comes from unstorage, which is a simple key value store client that is available in every SolidStart application by default. So we're going to create a storage client which right now uses a file system, but it could be using anything like Redis behind the scenes. And we're going to pass that as the first argument to our persisted signal. The second argument is a key. This is the key that we're going to use in the storage to store and retrieve our to-dos data. And of course, we have our initial or default value as the third argument. And just with that change, now if we add anything to our to-do list, go back here, quit the server, start it again, and now if we refresh, all the data is still going to be there. Pretty amazing. This also ensures that you can horizontally scale out your WebSocket servers as much as you want, as long as they use a key value store that supports watching, so something like Redis. All your servers are going to stay in sync. Finally, let's bring back some multiplayer goodness into our to-do list by allowing the users to invite a different user into their own to-do list to collaborate. We'll start by creating a deeply nested store that will have all the invites that have been sent out in the application. Then we are going to create our use invites hook, which will expose the add invite and remove invite methods for the currently signed in user to invite someone to their to-do list or to remove an existing invitation. Then we are going to return our add invite and remove invite methods along with two different signals. Now here we're using create socket store. This is a variation of create socket memo, which exposes a deeply nested reactive store to the client, which means instead of sending the updates down to the clients whenever anything changes, client can listen to specific keys inside the store and only receive updates when those specific keys change instead of the entire thing. It's basically how SolidJS stores work normally, but over the wire. The first one here is a list of all the to-do lists that the current user has been invited to. And the second one is a list of users that I have invited to my list. We can also now go back to our use server to-dos hook that currently only gives the user access to their own list. We can have it take the requested list ID as input. So this is the list ID that the current user wants to access. And in our list ID function, we can check our invite store to to check if the currently signed in user has access to the requested list. If they do, we're going to return that, and if not, we're just going to return the user ID, which means the user will not get access to the requested list. Instead, they'll simply get access to their current list. You might want to throw an error here instead, saying that you requested a list but it's not actually available to you, but I've left that as an exercise to the reader. And you can imagine what the UI for this would look like, so I'm not going to go into too much detail on that. So we use the useSocket directive to denote logic that should run on WebSocket servers. We use createSocketMemo to transport reactive values across WebSockets. We use createSocketStore to expose a fine-grained reactive store. We use cookies to authorize the user without any extra authentication steps. We use a persisted signal to store the data and share it among many servers. And we use event logs to automatically synchronize state between the client and the server. These are all the features that you get out of the box when you use SolidSocket library to build real-time apps on top of SolidStart. There's a lot more coming, so stay tuned. If you like the project, once again, please hop over to the SolidHack submission site and give this project a vote. I would really, really appreciate it.